Have you ever truly felt the world around you? Press your hand against a wall. It feels solid, unyielding, a boundary between you and something else. This sense of solidity is the bedrock of our reality. As children, we learn, don't run into the wall, don't fall off the chair. The world is made of hard stuff. But what if I told you this certainty of touch is a grand illusion? The wall, your hand, everything you know as solid, is almost entirely empty space. Imagine shrinking down into the heart of that wall. The familiar surface dissolves into a strange, mountainous terrain, then into vast emptiness, dotted with shimmering points of light. This is the world of the atom, where solid loses all meaning. You are not touching the wall. The wall is not touching you. What you feel is an electromagnetic force field, a ghostly push between two clouds of energy. The universe we perceive is a story told by our senses, simplified for survival. Our brains evolved to navigate predators and prey, not quantum mysteries. The chair you're sitting on is a phantom atomic nuclei suspended in a near-perfect vacuum, held together by invisible forces. The feeling of support is real, but its source is far stranger than you imagine. Let's peel back the curtain of everyday experience and peer into the machinery of reality. We'll travel to a place where things can be in multiple places at once, where particles are connected across galaxies, and where empty space is anything but empty. This is not science fiction. This is the fundamental nature of our cosmos. It's a world that defies common sense, yet it builds everything we see, touch, and are. Prepare to question everything you think you know about the solid ground beneath your feet. The universe is stranger than it appears. What you feel as solid is a dance of invisible forces. Reality is not what it seems. Welcome to the quantum world. Our journey continues, deeper into the heart of matter. Picture an atom as a vast cathedral. At the center, almost impossibly small, is the nucleus, a dense core of protons and neutrons. The rest of the cathedral, over 99.9999% of the atom's volume, is the domain of electrons. The stuff we're made of is mostly nothing at all. The universe, at its core, is defined by emptiness. Where are the electrons? Old models pictured them as tiny planets orbiting the nucleus, but the quantum world is stranger. An electron isn't a solid ball. It exists as a probability cloud, a shimmering fog of all the places it could be. The electron is nowhere and everywhere at once, denser in some areas, thinner in others, a smear of potential. This is a radical departure from everyday experience. Toss a baseball, and you know its path. An electron lives in pure potential until we look for it. This is superposition. The electron is in all its possible states at once, a symphony of maybes. The solid world is built on this foundation of uncertainty. The chair you're sitting on isn't static. It's a dynamic collection of trillions of probability clouds, a cosmic dance of potential. Solidity is an emergent property, a collective agreement between countless atoms pushing against each other with electromagnetic fields. The universe isn't built from bricks, it's built from ghosts. It's a structure woven from threads of probability, a grand cathedral made of empty space and shimmering potential. The world you know is a mirage of certainty atop a sea of quantum possibility. Every object is a dance of chance and energy. The atom's cathedral is vast, echoing, and almost entirely empty. Welcome to the true architecture of reality. An electron exists as a cloud of possibilities, a state of superposition. But when we try to find it, the act of observation changes everything. The moment you measure an electron, its probability cloud collapses, the wave of potential vanishes, and a single definite particle appears. Your attention, your measurement, fundamentally alters reality. Before you observe it, the electron is a wave of possibility. After, it's a particle in a single place. This is the observer effect. You are not a passive spectator, but an active participant in creation. The universe holds its breath in infinite possibility until a conscious observer, or even a measuring device, interacts with it. Every act of seeing collapses countless quantum wave functions, creating the solid reality you perceive. We shape the universe, one observation at a time. The quantum world has another trick: quantum entanglement, what Einstein called spooky action at a distance. Two particles can be created so their fates are forever linked, no matter how far apart they travel. Measure one's spin, and you instantly know the other's, even if it's across the galaxy. This connection is instantaneous, seemingly violating the speed of light. Einstein thought there must be hidden variables, but experiments proved otherwise. The universe is in fact spooky. Entangled particles are not separate, they are a single system, sharing existence across vast distances. This isn't just theory. Quantum computing and secure communication now harness entanglement for revolutionary technology. The spooky action that puzzled Einstein is becoming the foundation for the technology of the future. The universe's deepest mysteries are unlocking its greatest potentials. Entanglement is real, and it's changing our world. Quantum entanglement forces us to reconsider our assumptions about space and separation. We see the universe as separate objects scattered across a vast stage, but entanglement hints at a deeper unity. In the Big Bang, all matter and energy were once a single unified state. Could particles still be entangled from that moment? The separation we see may not be the ultimate truth. The universe is not a collection of isolated objects, but a single coherent whole. The actions of a particle here could correlate with one across the universe, not by signal, but because they were never truly separate. We are not just inhabitants of the universe, we are the universe, connected by a cosmic web. Quantum mechanics reveals a connection deeper than we ever imagined. What is empty space? For centuries, we thought of it as nothing, a void, but quantum mechanics reveals that empty space is not empty at all. It's a seething, bubbling cauldron of activity particles constantly popping into existence and annihilating each other. This is the quantum foam, or zero-point field. The uncertainty principle means there's a limit to how empty space can be. Virtual particles burst into existence, then vanish in an instant. This isn't just theory. The Casimir effect proves the quantum foam is real. Place two metal plates close together in a vacuum, and they're pushed together by invisible quantum forces. Empty space has real, measurable effects. The void has a pulse. Even in the emptiest regions, there's a fundamental energy, a cosmic hum that underpins all reality. The vacuum is not absence, it's the cradle of being. The zero-point field contains staggering energy. Calculations suggest a coffee cup's worth of empty space could boil all Earth's oceans. This is the vacuum catastrophe. Why don't we feel this enormous energy? The prevailing theory is balance. Positive and negative fluctuations cancel out, leaving a net energy close to zero. We move through this ocean of energy unnoticed, like fish unaware of water. But the balance isn't perfect. The universe's expansion is accelerating, driven by dark energy. Possibly, a tiny imperfection in the vacuum energy. The ghostly flicker of virtual particles might be pushing the cosmos apart. The fate of galaxies could be written in the subtle energy of nothing. The emptiness of space is not just a stage, it's an actor shaping everything. The smallest scales connect to the largest, uniting quantum foam and cosmic destiny. We began with the solid reality of a wall and found it was an illusion, a trick of electromagnetic repulsion. The atom is a ghostly cathedral, almost entirely empty space. The electron is a shimmering cloud of probability, real only when observed. Particles are mysteriously linked across galaxies, and even emptiness hides a seething cauldron of energy. If matter and space are illusions, what is real? The universe is not made of things, but of fields, probabilities, and relationships. We are not passive witnesses, we are the universe's way of knowing itself. The grand illusion is the belief that we are separate from the world we observe. Quantum physics teaches us that separation is a fiction. We are woven from the same quantum fabric as the stars and the void. Reality is a network of relationships, a tapestry woven from probability. We reach the end of our journey but the beginning of a universe of questions. The deeper we look, the more mysterious reality becomes. Quantum mechanics gives us power and technology, but leaves us with profound questions. Why do we experience a stable reality from a world of quantum uncertainty? Is our universe fine-tuned for life, or are there countless universes with different laws? The quantum world reminds us to be humble. What we perceive is not the whole story. The quest to understand is the great adventure of science, connecting the smallest flicker to the fate of the cosmos. The universe is stranger than we can imagine. You are not just a speck of dust, you are a piece of the cosmos, aware of itself. The story of our universe and our place within it is the greatest story of all.